Okay, there's a reason why I taught you 5-number summary, even though the ordinary Year 10 textbook doesn't ask you to do that. Because I teach Year 11 and Year 12 General Maths, and you might as well know about it now. Okay? Why is knowing the 5-number summary important? Because have you seen graphs like this before? You might have called them box and whisker plots in previous years. A box plot is literally just a diagram of the 5-number summary. Okay? A box plot has the elements below, so this is what you should copy for your notes. You just get the same idea of it. I don't need you to have the exact same scale. I just need you to show that there's a longer middle line, which represents the median, a rectangular box surrounding the median line. You have horizontal lines, which are the whiskers, and then you have shorter lines positioned over the min and the max. So why is it useful to find the 5-number summary? Well, that helps you decide how long the x-axis should be. The x-axis should fit your min and max. The median line is longer, placed over the median. The min and max lines are shorter, placed over the min and max on the x-axis. Q1 and Q3 lines are shorter vertical lines. The box connects Q1 and Q3. And the whiskers connects the min and the max to the boxes. I'll give you time to get what you need there, please. If you already know it, don't bother to note it down. If you get it wrong, I'll say I told you so. Some of you looking ahead on the timeline a little worried they're behind. You're always ahead regardless. So we're going to do 4 weeks of Year 11 work at the end. That wasn't accessible, so you're just going to chill out anyway. If we finish with finance by the end of this term, we'll finish off Year 10 in the first 2 weeks, and then I'll give you some head start on Year 11, okay? That head start will be a focus on some method material that I think is harder, okay? So just get this little blue box down to give you an idea of what a box plot is, or a box and whisker plot. Do you need something to write with? I've been slowly getting your mark DIs out during the week, but they will be finished over this weekend, okay? Your 12s are marked, your mainstreamers are marked. I'll try for Sunday because I want Monday off. So I'm going to have a heart attack if I move this. Okay, you would have remembered at the start of this whole topic, we talked about the skew of column graphs. So if I did a quick diagram of a column graph, if I had more data on the high end, we said that was negatively skewed. If I had more data on the, that's on the low end, that would be, there's more data here on the low end, so we called that positively skewed. If there's more data on the high end of a column graph, we call that negatively skewed, And if it looked the same on either side, we said it was symmetrical. You can tell the exact same things from a box plot. Much like column graphs and histograms, box plots can indicate the shape of data sets. So if your box plot is the same on either side of the median, you would call that symmetrical. That should be logical. Can you see that this box plot is compressed towards the left-hand side, the lower end? Just review back to this. If this box plot represents 100% of the data, right, and the median is in the middle, how much of the data is on this side? Say louder. If I've split 100% of something in the middle, how much of it is going to be on this side? 50% of it? How much is on this side? And what could you say about how this 50% is spread out? Is it more spread out or less spread out? It's more spread out. It's like spread out. It's spread out thin like Vegemite on a piece of toast. Whereas this, oh, it's frozen. This 50%, that 50% is data is spread out like bloody Nutella on toast. You want it like 2 inches thick, all right? So here, there would be more data on the low end, so it looks like this. So it's positively skewed. Where is the compression happening on the box plot on this side? On the high end or the low end? High end, so that would be negatively skewed. Can you get those 3 examples down, please? And then I'll demonstrate. His cat was sick. Are you talking about your cat? Glenn?
Oh, my cat?
Yeah.
No, not really.
That was like, I was interviewing you at home and I was like patting him.
Yes, my cats are very friendly.
Very friendly. I felt like an evil dictator or something. He was just on my lap and I was like... So get those little shapes down for your box plots, for skewness. I'd like to run an example of this. All right, I have a data set here. It's written raw. Is that data set in order? No? Can I easily find the 5-number summary for it right now? What do I need to do to find the 5-number summary? Put it in numerical order. So if I wanted to write it in numerical order, I want to find the 5-number summary in numerical order. What's the smallest number in that data set? 2. Next. Is there just 1 3 or? Yeah. Next.
3 4s.
2 3. Next. 2 5s. 1 2. Next.
5 6s.
1 2 3 4 5. 2 3 4 5. Next. 7 7. 8s. Last. Okay, we've ordered it now. Construct a 5-number summary. Do I need a formula to work out the minimum? No, you just freaking look at it. It's 2. How do I need a formula to find the maximum? No, it's 9. Now I need a formula to find the median. How many numbers are there? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. I believe there's 17. The position of the median is equal to 17 plus 1 over 2th position. So it's 18 over 2th position. The 9th position is the median of the whole data set. So 1, 2, 3, 4, 5, 6, 7, 8, 9. It's the middle 6. It's the second 6 is the median. Then hopefully from Monday's video you would have seen that the quartile 1 is the median of the upper half, and quartile 1 is the median of the lower half, and quartile 3 is the median of the upper half. So, if you have the median is one of the numbers in the middle, this is the upper half, and this is the lower half. So now we need another formula to work out how many numbers are there. 1, 2, 3, 4, 5, 6, 7. There's 8 numbers below. So the quartiles, median, is going to be 8 plus 1 over 2, 9 over 2, it's going to be the 4.5. So where is the quartile going to be? Halfway between which? 4 and 5. So quartile 1 is going to be there. What's the average of 4 and 4? 4. What's the average of 7 and 7? Good. So we have the 5-number summary. I just haven't written out. I can see it. Okay? B, draw a box plot to display the data set. Is my scale going to fit this?
Yeah.
Because what's the minimum? 2. 2 is going to fit. Is the max 9, so it's going to fit there. So you help me draw this. Where is the long line going to be for the median? Number 6. Where is the shorter line for the min going to be? 2. Max? Where is the left-hand side of the box going to be? Where's the right-hand side of the box going to be? 7. You can see it's not symmetrical, so we're going to have a skewness to this. What does it ask you to do now? Find the range of the data. The range is the biggest. Take the smallest, so the range is going to be 7. The interquartile range is going to be Q3, which is 7, minus Q1, 4. So 3. Then D, comment on the shape of the data set. Where is this compressed? On the high end or the low end? High end, because you've got the box is squished there, and also the whisker is more squished than that. So what kind of skew is it when you've got more data on the high end? Negatively skewed. It's the opposite of what you think. I believe that's the end of that. So I'll stop the video there.